Hi, good morning, class.
Good morning, ma'am.
I'm Dr. Aidaya from the University of the Philippines, National Institute for Science and Mathematics Education Development. I'm a science education specialist in that institute. Okay, so for today, we're going to have as our topic, deaths of solids. Okay, now I have here, have you seen these products before?
Yes.
Where?
Supermarket.
Supermarkets. Do you buy these products? Okay, so I have here a box of toothpaste, right? So I'd like Abigail, please face your classmates and describe this box.
This pack of toothpaste is color red and has 4 sides which has a shape of rectangle and 2 sides which has a shape of a square. So I think this pack of toothpaste is a rectangle prism
How sure are you that this is a rectangle?
because it has 2 pair of sides or 2 pair of sides wherein the 2 parallel sides are equal, I think so, and the other 2 are also parallel.
Okay, and you're telling us that this is a square, right?
Yes, most possibly.
How are you going to verify whether that is a square?
One of the properties of a square is that it has 4 equal sides. So to make sure that this is a square, we must measure the 4 sides and see if it is equal.
But- okay, so is it?
Looks like.
Looks like.
It looks like, but
Okay, it
we're
looks
not
like
sure.
a square.
But-
You like to verify it?
Yes, ma'am.
How?
Maybe by using a ruler
A ruler?
or yes,
Maybe you can use your
finger.
okay, we'll try to see. Just verify. Oh, so it looks like a square.
Yes, ma'am. It's a square.
Okay. You mentioned a while ago that this looks like a rectangular prism, right?
Yes.
Okay. So if you touch this part of the box, what do you call this? Okay. Mary Grace, come here in front. Okay. So we have here some parts of the box.
Yes, ma'am.
Okay. And then you said, what do you call these parts here? We can't explain to them.
Parts, lateral faces of the rectangular prism. These parts. And this one, the small squares, as Abby has mentioned a while ago, we call them bases of the rectangular prism.
Okay. Do you agree, Carmelo?
Yes, ma'am. I certainly agree with what my classmate here just said.
So these are the lateral faces, and you have here your bases.
Yes, ma'am.
But are bases also faces?
Bases are also faces.
Okay, so how many faces do we have here now?
There are 6 faces.
Okay, so there are 6 faces in a rectangular prism. Okay, now let's get another one. Okay. Okay, here. Okay, Fritz, will you kindly come in front and describe this?
So, okay, classmates, we have here in front a cylinder which have 2 bases, here and this one, and its lateral surface, this one. Okay, ma'am.
Okay, so this is the lateral face.
Yes,
How about this?
the bases.
The bases, or
The faces.
can we call this also faces?
Yeah, yes, ma'am.
Okay, so faces are something that is what? When you touch? When you touch it, what's the feel? Is it curved? Is it flat?
It's flat.
It's flat. The bases are flat.
Yes, ma'am.
Okay. Now, do you have vertices in this case? You know what a vertex is? Can you recall what a vertex is? A vertex. Do we have vertices here in this box?
Yes, ma'am.
Where are the vertices?
The edge.
Lovely. Will you kindly point to your classmates where the vertices are?
So this one is an example of vertices in this.
Okay, so how many vertices are there in that prism?
We have 8 vertices.
Okay, so we have 8. Okay. How about this one here? Do you have vertices? Not. Okay, so not. Now, how about edges in this case? You know what an edge is?
Yes.
Cheryl, what is an edge?
Okay, so ma'am, classmates, this is an example of the edge of the rectangular prism, and also this one.
How many edges are there?
12.
12. Are you sure? Okay, so there are 12 edges, and you have 8 vertices, and then you have 6 faces in this case. Okay, now if I'm going to group this, okay, what we call them? This, suppose I group them, okay, and this one here. Okay, so what do we call this? We have the prisms. Okay, how about these two? Or 3, okay? Cylinders. We have what we call the cylinders. And how about, although this is not so round, how about this ball here? Sphere. And then, of course, what something is missing. So what is this? Cone. Are you sure it's a cone? Yes. It's a cone but without ice cream. Okay? So, who would like to come in front? Say, Marilu, come here and describe the cone.
As we can see, one of the characteristics of this cone has one base, which is circle, and
Okay.
an endpoint, one endpoint, or
Which is called?
vertex.
Okay, vertex. Okay. Now, I can find in the grocery something that looks like a pyramid. So, let's just look at this. Okay. So, this is what you call a pyramid. Okay, so will you, Paula, kindly describe what a pyramid looks like?
Okay, classmates, so I have here a pyramid, and as you can see, we have some faces that looks like triangle, and its base, another triangle in form. So I can touch it.
Okay, so what we call this?
It has an vertex. We have
How many vertices?
four
Vertices.
four vertices, ma'am.
Okay, how many edges do you have there?
We have here 6
6.
edges also.
And then how many faces do you have?
5 faces also.
Are there 5?
Sorry, ma'am. It's 4.
4.
Rather than.
Okay, so we have 4 faces, and then you have 6 edges, and then you have 4 vertices. Okay, I'm so happy that you can still recall your special figures, like a prism, how it looks like, and then a pyramid, a sphere, and your cylinder. Okay, so for today, I have here a box. Okay. Okay, now what are you going to do with the box? I would like you to flatten this box. Okay? Now, on your paper, will you kindly draw? What do you expect? If you are going to flatten this box, what pattern can you form? Okay? So will you kindly draw before we explore? And then later on, we're going to see whether your drawing is correct or not. Okay? Okay, I'm going to divide our class into 6 groups. Okay? Now, each group will get 1 box and 1 cutter. What you're going to do is to flatten this box, okay? This box using the cutter. As you do so, okay, try to remember how many cuts you did in flattening this box. Okay, because later on we're going to discuss, will it be 6 or 7 or 8 or whatsoever. The least number of cuts, okay, to flatten this box. Okay, so in our activity, I asked you to flatten this box, right? Yes. And as I move around, I saw different patterns form. So it's now time for you to share what you did. Okay, can I call a representative from Group 1 to show the pattern they were able to form? Joyce?
Okay, so in our group, from this solid figure, we are asked to flatten this figure. So first, we started on one of the faces of this figure. So on this face, we got the 3 edges. We have the first, second, and third edges. So we have this. Then we had the base. We had 2 cuts on the base. So we have 1 and 2 cuts. One, two. And again, for the faces, we have 1 and 2 cuts. 1 and 2. So we had this pattern for flattening the solid figure.
So how many cuts did you make?
We had 7 cuts.
The 7 cuts in order to flatten the box. Okay?
Yes.
So can you kindly post it there? Okay, how about group 2? Can you show a pattern different from this? Were you able to form one?
Yes, ma'am.
Okay, Abigail, can you show it to your classmates?
Okay. So this is the original figure that we have. So first we cut the top face. So we have 3 cuts, 1, 2, and 3. Okay, then we have that. Then the 4th cut will be here at the side, this edge. So we'll have this one. Okay, it has been cut. And next, the bottom base. We have 1, 2 cuts. 1, 2, and another cut here. So we have this pattern. Overall, we have 7 cuts.
Okay, is it that different from the first group's work?
Yes, ma'am.
Okay, so can you post it there? Okay, so we now have 2 patterns different from each other. How about group 3? Do you have a pattern different from those 2 patterns? Okay, Fritz?
Okay, this is the work of group number 3. So we have this original box. So we have cut this box along these edges, 1, 2, and 3. So we have this cut. And then our group have cut this edge again and the other side. So we have this figure. And lastly, we have cutted this edge and this one. So we have this figure. So all in all, we have 7 cuts to make this figure, which is obviously different from these 2.
Okay. Okay, how about group 4?
Yes, ma'am.
Okay, can you show your pattern?
So our group will show a pattern that is different from their pattern. So first, we cut the top base of this figure. So we have 3 cuts. From here, we have it 1 cut here, and the other is here. So we have the figure. So we have it first, this one, and then we got the one edge of the lateral face. So we cut it here. Okay. So and then on the bottom part of the figure, we also cut 3 edges. So we have 1, 2, and 3, and then so we have. Okay. So since we already cut the lateral edge of the edge of the lateral face, so we have the figure. That is different from their pattern.
Okay, good. Okay, how about group 5?
Yes, ma'am.
Okay, Andrew?
Okay, our group worked with the top face or the top base. So we cut the 3 edges, so 1, 2, and 3. So we have this one. And then we work with the edges of the lateral faces. So we have cut all the 4 edges. So we have 1, 2, 3, and 4. And then we form this figure.
Okay, so that is different from
Yes, that is different
previous
from
patterns.
Yes, ma'am.
Okay? Okay, and group 6, can you add to our patterns here on the board? Do you have? Okay, so Leah.
Okay, so this is the word of our group, 2.6. So we flatten this surface by cutting it 7 times. So first, we cut the upper base with the 3 edges. So we have here 1, 2, 3. And then the other base, we cut also 3 times. So we have here 1, 2, and then 3. And then one edge of a lateral face. So we have this pattern.
So this one is the, look at this,
Yes.
okay?
Not the same.
That's the-
This face is different from this face. Okay, so can we classify them as different patterns for the
Yes,
box?
ma'am.
Okay, so we can count that as a different pattern. Okay, from our activity, we were able to find many patterns for one box, right? Okay, so I'd like you to point out on these patterns, okay, the edges, the vertices, and the faces of this box. Okay, so remember, how many faces do we have?
6.
We have 6. So can you point to us the 6 faces here? Lovely. Just use one pattern and then point out to us the faces of the box.
So these are the faces of the box.
Okay, so there are 6 faces, okay? How many vertices do we have?
8.
8. Okay, who'd like to come in front and then point to us the 8 vertices of the box? Would like to do that? Mika? Can you point to us the 8 vertices? You can mark it using this pen. Okay, that's 1. That's 2, 3,
1.
so you have 8 vertices already? No, 2, 3,
4, 5.
so hard to imagine. So try to fold the box, so that will guide you. So 1, 2, 3 are going to have a vertex here. If you try to fold it that way, so this will be your 4th.
This one and this.
Okay, so that will be, okay, so try to,
This one and
you have so many X's. Can you just place 1, 2, 3, 4, 5? So if you have 4, for example, this, let's try to write. This is 1, this is 2, 3, this is 4,
this one and
4. So if you fold it that way,
this one.
so will you try to, will this be a vertex?
Yes.
With what?
This one.
Okay, so you place here, say 5, and then 5, okay? So, continue. So try to fold, you should have 8. So 6, 6. Then you have 7. Where's the 8th one? So 8, 8. How about this corner here? What will happen to this?
7.
So which one? Is what number?
7.
It should be 7. Okay? So you have now it's more difficult, right, to imagine where the vertices are. Okay, so how about the edges? How many edges do we have? 12. Would like to come in front and then point to us the 8 edges. You can fold it as you count, okay? And Ariel.
In this pattern, there will be 4 edges on the bottom base.
Okay, will you kindly number it and also? Okay, so here, where are the edges?
This one,
1, 2, 3, 5, 6, 6. Okay.
7,
So where's the 8? 8. 8, okay. 9. 10, 10. Okay, you have the 12. Can you check it? Let's try checking. Will you fold it? So let's see whether you have really 7, 7, okay. 9, 9, very good. And then we have 12. Where's the 12? So 11, 12, okay, very good. Okay, so you have now the 12 edges. Okay? Any questions so far? Okay, so what we're going to do now is, we're going to have 6 groups. For each group, I'm going to give you one solid. Then try to make one pattern. Okay? Only one pattern will do for each of the solids. So this will be your group 1. You can have a bond paper, just draw. Okay. Then you're going to share it later. This will be our group 2. Yummy. Okay. And then group 3. Just one pattern. 3. And then group 4. Maybe 4 of you will work on it. And then
May dalawang hexagon sa baba.
group 5. Now, try to imagine this to be a spear. Okay? It's not actually a spear. Looks like a spear. Okay, so, and then, can you work on that? Or you like to work on another shape? Okay, work on another shape.
Ano may nag-gets mo? Baba ka? Yeah.
No, you cannot cut. You cannot cut. Try to visualize what will happen if you're going to flatten the solid.
Marka na lang natin na 1 yun.
This time you're not going to cut. Okay? Imagine, supposing you're going to flatten it, what will happen? Then we're going to verify later. Okay? Use your imagination.
Kailan ka siya ba? Kasya nila yung 2.
Okay, work together.
6 eh. 6. Ito na yung hawak ko eh. Oo nga kasya. Sige, kasya na. Game. Hirap din makita eh. Ayusin na lang natin later. Pwede mo. Sige, saan? Okay na, 6 na. Sa kabila natin.
Can we now discuss your work? Okay, so let's start with group 1.
7, 8, 9.
Who will be the representative for group 1?
Vertices.
Okay, Paula?
4, 5, 6. 12 lang. 2, 3, 4, 5.
Okay, classmates. So we are assigned with the solid figure, which is a square pyramid. So we have 4 cuts here. So we have the edge. This 1, 2, 3, and 4 until we've come up a pattern which looks like this one.
Do you agree? Are you convinced?
Yes.
Really?
Yes.
Okay, so if you cut this,
Faces 8.
maybe you can just use your imagination. But if you like to verify, try to cut. Okay, and then try to fold.
So I'm going to fold now.
Okay. Okay. Okay, very good. Okay? So, do you think you can find other patterns besides this one?
Yes.
Okay, how? Can you guess one pattern different from this? Paula.
Ma'am, by cutting the edges of the base.
Okay, so you can cut here and then place beside this triangle.
Then one edge from the triangle face.
Okay, so there are many patterns, okay, from this solid. You can draw from this solid. Okay, how about this group? Are you ready? Oh, okay. You just show it.
So our group designed with this figure. I think this is a trapezoidal prism because it has two bases of trapezoid. Then we are able to make a sketch like this one. So if we were going to
We're going to cut.
if we're going to cut this edge and we'll lay this down, we'll arrive at this side.
Figure. This will be the figure, just like
This one here. Okay, but notice that this length should be the same as.
Yes, ma'am.
Okay, so this is simply a rough sketch of the pattern. Okay? Okay, very good. Your group is ready? Okay. Who will present it for your group?
Both of us.
Okay, okay. Very good, St. John.
Okay, from this hexagonal prism, we form a net like this. So that has a total of 12 vertices, 18 edges. If we'll connect, we cut it in one edge, one of the lateral face, here this one, and then all the remaining 5 edges of the bumps, of the bases. So we form a net like that.
You said that is an hexagonal prism. Why? Why do you call that hexagonal prism?
Because the base is a hexagon. So, and it is a prism because it has, it is a 3-dimensional figure, just the base and the lateral faces.
Okay, you have 2 parallel bases.
Yes, ma'am.
Having the same shape. Okay, so you have your... But can you have another pattern for this? Do you think?
Yes.
by first
We could move the bases
Okay.
in the edges.
Do you think this is a regular hexagonal prism?
Yes. Because all the faces are parallel and parallel to the base. So they are the same.
And there's another condition, and to be irregular,
But the sides of the bases are equal, the same shape.
okay, so you should have, in order to call this a regular hexagonal prism, you should have the same length, okay? To become a regular hexagonal prism. Okay, I think you're ready, Fritz? Mika? Okay, Stephanie?
Two of them.
Okay, 2 of them, present.
So we have a cylinder here. This is the top base. This represents the bottom base. And this represents the surface. If we just fold it in a way, we're gonna have the same cylinder, but different size because we lack hot paper.
Okay, just remember that the circumference of the circle must be what? Equal to?
The length of the
Okay, the length of the rectangle.
Yes.
Okay, because you're going to wrap it around the circle. Okay, so you have here your cylinder. Actually, you have to detach this, right? And then these circles here can move,
Yes.
okay, along the sides of the rectangle. Okay, thank you very much. And can we have the next group? We have the sphere, the last one, special. The special group.
Here we have an octagonal prism. We've got the sides and stuck one side to the center of those 8.
Okay, so will you kindly fold it? Okay, so that will be the bases. Okay, so those are the bases, and then you have the lateral faces here. Okay, can we have now the sphere? We'll present it here. Now, that is the challenge. How are you going to flatten the sphere?
Okay, this is really a challenge for us. But we do some visualizations and we cannot cut this out. So we do like a globe, a map that we see in the library. Since we cannot do it on a cut out, so we just illustrate it as this one.
And then you just form it. Are you sure that will form a sphere?
Some
Try the smaller version.
We have the smaller version.
Yes, ma'am.
It will look like a sphere. Are you sure?
So, this is the finished product.
Come here, Ariel. Show to the group.
When this is cut out, this part and this part will meet each other, and then the top part, this jagged edges will meet at the top at one point, and hopefully it will form.
Hopefully.
We tried small cuts and long ones, but
Okay.
I think the small cuts work.
The smaller it because the more it resembles a spear. Are you sure? Not quite. Any other idea how you're going to show the net of the spear? Do you think that's correct?
Yes.
Is that correct? Okay. I have here, let's verify, okay, because spear is the special one. Okay, the special spatial part, spatial shape, okay? Going to cut. Okay, assuming that this is a spear, looks like a spear, okay? I need, oh, what is happening, Mom? Okay, oops. So, parang, we feel it, oh, it's juicy. We cannot eat that anymore, sorry. Okay, so we try to remove the peeling. Oops, okay, so here, if we place it here, what will happen?
Spiral.
Because it's not flattened, right?
Yes.
So what do you think will be formed? If you continue with this one here. What is the shape?
Like a dartboard.
But has
Looks like what?
Yeah.
open.
Can somebody help me pick that up?
Tornado.
It will look like this. Okay? So, which two-dimensional figure does this resembles? And continue on. What shape can you see? Okay, it's circle in form. Okay? So that will be the pattern for your spear. But now, what is the relation of the radius of this pattern here with the radius of the spear? That is for you to investigate. Okay. So, if you have the spear, you have a radius for the spear, right?
Yes.
Okay, and then you try to flatten it. This will be a possible, okay, pattern for your. Okay, you're going to have this. Okay, it will be a circle actually. But what I'd like to investigate is what is the relation of the radius of that circle and the radius of this spear? Can you guess? Suppose you have the, what do you think? This is the spear. Okay?
1/4 ng ano yung malaki.
So what do you think?
1/4 ng malaki. Kasi yung
The spear will be, if we're going to have the reflection of the spear here, okay, that will be the spear, its outline. This is now the pattern, okay, that we had formed. Okay? So what do you think is the relation of the radius of this spear and the radius of this? Your circle.
half the radius.
It should be, it looks like what? Do you think it's twice? The radius of the circle here is twice that of
The sphere.
Okay, so that will be your homework. Okay, so tomorrow go to report to me whether it's really twice. Okay, is it about twice that of the radius of this sphere? That's for you to investigate. Okay, so that will be your first assignment for tomorrow. Okay? Okay, now, as a challenge, we go now to the other one. Suppose you are now given the pattern. Do you think you can form the solid?
Yes.
Are you sure?
Yes.
Okay, so let's try this. Okay, again, I have here some patterns. Okay? You're not going to connect them. Try to sketch first what will be the solid that will be formed from this. Okay? And then afterwards, try to connect now and verify whether your drawing is correct or not. Okay? So you choose. So they won't have the spear. Alright, choose. Choose anyone. Any pattern. Okay. How about your group? How about your group?
Sige, Joshua. 1, 2, 3, 4, 5, 6.
Draw first. The special group, are you done?
Yes, ma'am.
Okay, so we start from your group.
This time, classmates, our group has been given a figure that is called pentagonal pyramid, wherein, given this form, if we are able to really solve this figure, we find out that there are 6 faces, as well as its vertices has already 6, and also the edges will be summing up with 10. And then it is called pentagonal pyramid because of its base that has 5 sides.
Okay. Any questions? Okay, very good.
Thank you, ma'am.
Okay, next group, Marilu, your group.
We are assigned to figure out what form or what solid figure will form in this paper. And we come up with a cone which has one vertex and a circle as a base.
Any questions? None. Now, what is the relationship between the circumference of this circle with respect to this one here? To the arc. You have a sector, right?
The circumference of this circle must be equal to the arc.
Okay, so the circumference of this circle must be equal to the length of the arc. Because if you're going to fold it, okay, this way, so these two must be of the same length. Okay, very good. You can post it there. Okay.
So classmates, given the net of the solid, which is this, we come up with a figure which is a hexagonal pyramid. Okay, so if we will fold by connecting the edge of these 2 lateral faces with the edges of the base, we will have a figure like this. The hexagonal pyramid has 7 vertices, 7 faces, and 12 edges.
Okay, classmates, our group is assigned with this net of a certain solid, and we come up with this solid, which is a hexagonal prism. So if we try to check if it is correct, so we have to connect the 2 edges of these lateral faces. So we have this and the 2 bases. So we have this one. Okay, this hexagonal prism has 8 faces. So we have the 6 on this side and the 2 bases. Then 18 edges and 12 vertices.
Okay, with the given net, we have formed a cylinder. Okay, so a cylinder has the base of a circle. So we have 2 bases, 1, 2, and I draw some imaginary broken line here because the center of the circle should be aligned so that we could form the cylinder, and the rectangle, which will be wrapped around the circle, will be connected and exactly from the circumference, since we know that the circumference of the circle must be equal to the length of the rectangle.
Okay. Any questions?
No.
Actually, that's a right circular.
Right circular
cylinder.
cylinder.
Because you have the oblique ones,
Yes,
right?
ma'am.
Okay.
Okay, with this given net, we have formed a triangular prism. This triangular prism has two parallel bases, which are triangles. So, in this prism, triangular prism, there are six vertices, 9 edges, and 5 faces. So,
So if we fold this net, we will have this figure, which is a triangular prism. That's all.
Okay, thank you. Okay, so for today we had 2 activities, right?
Yes.
What's the first activity? Yes, Joanne?
So, first, we do something about the solid figure, and we cut it in for us to form the net of that solid.
Okay, so what do you observe? What have you found out?
In cutting the solid figure, we can have different kinds of pattern using that figure.
Okay, so from one solid